According to the 2023 National Electrical Code, Article 300.5d states that raceways exposed to different temperatures shall be provided with expansion fittings. Additionally, Article 300.5e states that raceways shall not be subject to undue physical damage. Expansion fittings are required when raceways are exposed to different temperatures, such as when they transition from underground to above ground. Conduit exposed to physical damage requires protection. A slip joint is a type of expansion fitting that allows the conduit to expand or contract without damaging the raceway or its content. It is typically installed at the point where the underground conduit transitions to the above-ground conduit. Firstly, the slip joint should be the correct size for the conduit used. Secondly, the slip joint should be securely attached to both the underground and above-ground conduits. Thirdly, the underground conduit should also be properly sealed to prevent water intrusion. When an underground conduit rises and is exposed above ground, it experiences temperature fluctuations different from the stable underground temperature. This difference causes the conduit to expand and contract. Without an expansion fitting, this movement can place stress on the conduit, potentially leading to damage at connection points or even within the conduit itself. The NEC mandates expansion fittings to mitigate this risk and ensure the long-term integrity of the electrical system. Now let's delve deeper into the practical considerations of installing slip joints. The selection of the appropriate slip joint depends on several factors, primarily the conduit material, the conduit size, and the anticipated temperature differential. Conduit materials like polyvinyl chloride, or PVC, have a higher coefficient of thermal expansion compared to metallic conduits like steel or aluminum. Therefore, PVC conduits generally require more frequent or larger expansion joints. The conduit size also plays a crucial role. Larger diameter conduits experience greater expansion and contraction for a given temperature change. Consequently, larger conduits may need expansion joints with a greater range of movement. Calculating the required expansion allowance involves using the coefficient of thermal expansion for the conduit material, the conduit length exposed to temperature variations, and the maximum expected temperature difference. This calculation will determine the minimum travel distance the expansion joint must accommodate. Proper installation is paramount for the effective functioning of slip joints. Firstly, ensure the slip joint is compatible with the conduit material and is rated for the intended application. Secondly, thoroughly clean and prepare the conduit ends before inserting them into the slip joint. Thirdly, securely tighten the slip joint fittings to the manufacturer's specified torque to prevent slippage or water ingress. Remember to apply appropriate thread sealant or lubricant to ensure a watertight and corrosion-resistant connection. Furthermore, consider the environmental factors at the installation site. In areas prone to flooding or high moisture levels, use waterproof slip joints and sealing compounds to protect the electrical system from water damage. Additionally, in locations subject to physical impact, such as near roadways or parking areas, provide additional protection for the exposed conduit and slip joint with concrete encasement or guard posts. It's also important to remember that the NEC doesn't provide a one-size-fits-all solution. The specific requirements for expansion fittings may vary based on local amendments and interpretations. Therefore, consult with local electrical inspectors and engineers to ensure compliance with all applicable regulations. Moreover, proper grounding and bonding are essential for the safety and performance of any electrical system. When installing expansion joints, ensure that the grounding and bonding conductors are properly sized and connected to maintain electrical continuity across the joint. Use grounding bushings or bonding dumpers to bypass the expansion joint and provide a reliable path for fault current. In summary, understanding and adhering to the NEC requirements for conduit expansion joints is crucial for ensuring the safety, reliability, and longevity of electrical installations. By selecting the appropriate expansion fittings, installing them correctly, and considering the environmental factors at the installation site, you can protect your electrical system from the damaging effects of thermal expansion and contraction. Always consult with qualified professionals and local authorities to ensure compliance with all applicable codes and regulations. Now, let's consider some practical examples of situations where expansion joints are critical. Firstly, imagine a long run of PVC conduit installed on the roof of a building. The roof is exposed to direct sunlight and experiences significant temperature variations throughout the day. Without expansion joints, the PVC conduit would expand and contract excessively, potentially causing it to buckle, crack, or separate at the joints. Secondly, picture an underground conduit run that transitions from a buried depth to an above-ground enclosure. The underground portion of the conduit remains at a relatively constant temperature, while the above-ground portion is exposed to ambient temperature fluctuations. An expansion joint at the transition point would accommodate the differential expansion and contraction, preventing stress on the conduit and the enclosure. Thirdly, consider a large industrial facility with extensive networks of electrical conduits running throughout the plant. These conduits may be subject to vibrations, mechanical stress, and temperature changes from various equipment and processes. Expansion joints strategically placed along these conduit runs would absorb these movements and stresses, protecting the electrical system from damage and ensuring its continuous operation. Furthermore, it is important to consider the potential for ground movement or settling, especially in areas with unstable soil conditions. If a conduit run is subjected to ground movement, it can place significant stress on the conduit and its connections. Expansion joints can help to accommodate this movement and prevent damage. The NEC provides specific guidelines for the installation of expansion fittings in various applications, including underground installations, above-ground installations, and installations in hazardous locations. These guidelines cover topics such as the type of expansion fitting required, the spacing between expansion fittings, and the proper methods for supporting and securing the conduit. It is essential to carefully review and follow these guidelines to ensure compliance with the code and to ensure the safety and reliability of the electrical system. Now let's talk about some common mistakes to avoid when installing expansion joints. Firstly, using the wrong type of expansion joint for the application. It is crucial to select an expansion joint that is compatible with the conduit material, the conduit size, and the anticipated temperature differential. Secondly, failing to properly clean and prepare the conduit ends before installing the expansion joint. This can lead to leaks or loose connections. Thirdly, over-tightening or under-tightening the expansion joint fittings. This can damage the expansion joint or cause it to fail prematurely. Fourthly, neglecting to provide proper support for the conduit and the expansion joint. This can cause the conduit to sag or move, putting stress on the expansion joint. Fifthly, failing to properly ground and bond the expansion joint. This can create a safety hazard and prevent the electrical system from functioning properly. By avoiding these common mistakes, you can ensure that your expansion joints are installed correctly and will provide years of reliable service. In addition to the technical aspects of expansion joints, it is also important to consider the aesthetic aspects. Expansion joints can be unsightly, especially if they are not properly installed. Therefore, it is important to choose expansion joints that are aesthetically pleasing and to install them in a way that minimizes their visual impact. For example, expansion joints can be painted to match the color of the conduit, or they can be hidden behind architectural features. Ultimately, the goal is to provide a safe and reliable electrical system that is also visually appealing. In conclusion, expansion joints are an essential component of any electrical system that is subject to temperature changes or ground movement. By understanding the NEC requirements for expansion joints, selecting the appropriate expansion fittings, installing them correctly, and avoiding common mistakes, you can ensure the safety, reliability, and longevity of your electrical system. Always consult with qualified professionals and local authorities to ensure compliance with all applicable codes and regulations. Let's dive into some specific scenarios where the application of NEC Article 300.5d becomes particularly relevant. Firstly, consider a large commercial building where the electrical service enters the building underground and then transitions to a vertical riser extending several stories high. The temperature difference between the underground environment and the upper floors of the building can be significant, especially during seasonal changes. Without expansion joints, the vertical conduit riser would be subjected to substantial thermal stress, potentially leading to damage to the conduit supports, the building structure, or even the conductors inside the conduit. Expansion joints strategically placed along the riser would accommodate this thermal expansion and contraction, ensuring the integrity of the electrical system. Secondly, imagine a wastewater treatment plant where electrical conduits are used to supply power to various pumps, motors, and control systems. These conduits are often exposed to corrosive chemicals, extreme temperatures, and constant moisture. In such harsh environments, the selection of appropriate conduit materials and expansion joint types is crucial. Corrosion-resistant conduits like stainless steel or fiberglass reinforced polymer, or FRP, should be used, along with expansion joints specifically designed for corrosive environments. Regular inspections and maintenance are also essential to ensure the continued reliability of the electrical system. Thirdly, consider a bridge or overpass where electrical conduits are installed to provide lighting, signaling, and other electrical services. Bridges and overpasses are subjected to constant vibrations, wind loads, and temperature changes. Expansion joints are necessary to accommodate these movements and prevent damage to the conduits. The expansion joints must be designed to withstand the specific environmental conditions and loading requirements of the bridge or overpass. Furthermore, it is essential to consider the potential for seismic activity in areas prone to earthquakes. In such areas, expansion joints must be designed to accommodate the expected ground movement and prevent the conduits from rupturing or collapsing. The NEC provides specific guidelines for the installation of expansion joints in seismic zones. It is also important to consider the potential for vandalism or theft when installing expansion joints in exposed locations. Expansion joints can be a target for vandals or thieves who may attempt to damage or steal them. To prevent this, expansion joints should be installed in secure locations and protected with tamper-resistant hardware. Security cameras and alarm systems can also be used to deter vandalism and theft. Now, let's talk about the different types of expansion joints available on the market. The most common type of expansion joint is the slip joint, which consists of two telescoping sleeves that slide within each other. Slip joints are relatively inexpensive and easy to install, but they have a limited range of movement. Another type of expansion joint is the bellows joint, which consists of a corrugated metal tube that expands and contracts like an accordion. Bellows joints have a larger range of movement than slip joints, but they are more expensive and require more careful installation. A third type of expansion joint is the ball joint, which consists of a ball and socket connection that allows for movement in multiple directions. Ball joints are typically used in applications where there is significant movement in multiple planes. The choice of expansion joint type depends on the specific application and the amount of movement that needs to be accommodated. It is important to consult with a qualified engineer or electrician to determine the appropriate type of expansion joint for your needs. In addition to the expansion joint itself, it is also important to consider the supporting hardware and accessories. Expansion joints must be properly supported to prevent sagging or misalignment. The support should be designed to accommodate the movement of the expansion joint without restricting its ability to expand and contract. Accessories such as grounding straps, bonding jumpers, and sealing compounds are also necessary to ensure the proper functioning and safety of the expansion joint. Always use high-quality hardware and accessories that are specifically designed for use with expansion joints. Let's delve into the specifics of calculating the required expansion allowance for a conduit run. This calculation is essential for selecting the correct size and type of expansion joint. Firstly, determine the length of the conduit run that is exposed to temperature variations. This is the distance between the 2 points where the conduit is anchored or supported. Secondly, determine the maximum and minimum temperatures that the conduit is likely to experience. This can be based on historical weather data or on measurements taken at the installation site. Thirdly, determine the coefficient of thermal expansion for the conduit material. This is a material property that indicates how much the material will expand or contract for each degree Celsius of Fahrenheit change in temperature. The coefficient of thermal expansion can be found in engineering handbooks or online resources. Fourthly, calculate the change in length of the conduit run using the following formula: delta L equals alpha times L times delta T, where delta L is the change in length, alpha is the coefficient of thermal expansion, L is the length of the conduit run, and delta T is the change in temperature. Fifthly, select an expansion joint that has a travel range that is greater than or equal to the calculated change in length. It is always better to err on the side of caution and select an expansion joint with a larger travel range than is strictly necessary. Finally, document your calculations and the selected expansion joint size for future reference. This documentation will be helpful for maintenance and troubleshooting purposes. Now, let's discuss the importance of proper grounding and bonding when installing expansion joints. Grounding and bonding are essential for ensuring the safety of electrical systems and for preventing electrical shock hazards. Where expansion joints are installed in a conduit run, they can interrupt the continuity of the grounding path. Therefore, it is necessary to provide a separate grounding conductor to bypass the expansion joint and maintain the continuity of the grounding path. The grounding conductor should be sized according to the NEC requirements and should be securely connected to the conduit on both sides of the expansion joint. In addition to grounding, bonding is also important. Bonding refers to the practice of connecting all metal parts of the electrical system together to create a low impedance path for fault current. This helps to prevent voltage differences between different metal parts, which can create a shock hazard. Expansion joints can also interrupt the continuity of the bonding path. Therefore, it is necessary to provide a bonding jumper to bypass the expansion joint and maintain the continuity of the bonding path. The bonding jumper should be sized according to the NEC requirements and should be securely connected to the conduit on both sides of the expansion joint. When installing grounding and bonding conductors, it is important to use appropriate hardware and techniques. Use grounding bushings to provide a secure connection between the grounding conductor and the conduit. Use lock washers to prevent the grounding bushings from loosening over time. Apply anti-oxidation compound to the connections to prevent corrosion. Follow all NEC requirements for grounding and bonding to ensure the safety of the electrical system. In summary, the installation of conduit expansion joints is a critical aspect of electrical system design and installation. By understanding the NEC requirements, selecting the appropriate expansion fittings, installing them correctly, and paying attention to grounding and bonding, you can ensure the safety, reliability, and longevity of your electrical system. Always consult with qualified professionals and local authorities to ensure compliance with all applicable codes and regulations.